First, thank you for having us. This is Fred, my colleague, and this is our presentation on automating cyber threat intelligence with a practical approach on emerging vulnerabilities. Agenda for today. It's just who we are, a background, setting the stage on what we do, where we come from, what our outputs are, how we automated our process from just a regular Excel spreadsheet to using some sort of SOAR automation workflow, how we took sort of deployments of honeypots to collect intelligence, just regular bash scripts, and we took that into a CI/CD platform. We took the output of that intelligence and we hunt around our customer databases and then telemetry to understand what the threats are in the real world. And takeaways, and if we have some time, we'll go ahead with some questions. So who we are. My name is Andy, Senior Security Researcher at Datadog. So I previously worked at Arista Networks doing threat research. Previously to that, I was doing incident response in Disney and in the financial industry. I previously taught incident response in a college in California, and I absolutely love all types of malware in any operating systems. Here's my LinkedIn if you want to connect.
And I'm Frederic. Good morning. So I'm also a senior security researcher at Datadog, mainly focusing on threat intelligence, malware analysis. Previously, I was a former CERT analyst and DFIR practitioner. I'm also an open source enthusiast, so trying to contribute to some open source projects, and also part of the Botconf organization committee.
Cool. So some background, setting the stage. What does threat research do at Datadog? So we are a pillar of security research. It's a department that we supplement the various detection teams, the CERT teams, and the publication teams. So our outcomes are rule ideation. So we help the various detection teams in Datadog for internal, for products, for all our customers, create new rules or new detection capabilities. We publish security advisors in security labs. That's our homepage. That's where all of our research goes. And we obviously sometimes try to do product improvements. Product managers sometimes don't listen. They have a different go-to-market strategy than what we do. We hunt and we collect intelligence. And obviously, we own the process of emerging vulnerabilities. So we classify vulnerability to be a priority, and we determine if it's emerging or not. So vulnerability, we all know what a vulnerability is. It's just a flaw in a computer system that overall weakens the posture of a device or system. So what you might ask, like, so what? We have a bunch of IR teams, we have CTI teams, vulnerability management teams. Like, we could handle that. We have established process. There is a SOC that monitors this. So why do we care? Well, if you look at the statistics here, it's just 2023, we have nearly around 30,000 vulnerabilities. That is, management will definitely freak out about that. Vulnerability management teams will not be able to handle that. Sort of CERT teams don't even want to, and that's just overwhelming for CTI teams to bring context on that. So we needed a way to like sort of classify. And even if you look at like what MVD says, like MVD has a backlog of enriches of vulnerabilities. So if MVD has a backlog saying that they have vulnerabilities submitted that they haven't even been able to get to, like we reached a certain problem. Like we have so many researchers auditing code and so much open source code nowadays that just vulnerabilities are meant to come out, and it's just the nature of development. So, and on top of that, to put a cherry on top, we have like CVEs gone viral. Like now we have CVEs with like logos, names, websites, like, okay, so on top of that, we have like the algorithms that push CVEs up and they just expand the exposure. And here's just a little take, we have Confluence always, Atlassian always coming up with RCEs. And then obviously 2 weeks ago, we had a huge, not vulnerability, but sort of backdoor for XCC. And last week, a Global Protect in Palo Alto didn't get to make the chat, but they joined it. So Fred here is going to give you a little sort of overview of how we took this process from like a manual Excel spreadsheet and we automated it into like a SOAR workflow.
Thanks, Andy. So yeah, the idea is to at least focus on the most relevant vulnerabilities we want to work on. So we decided to create, besides the existing CVSS base score, our own score by taking into account more information. Like, for example, taking into account that we are dealing with a remote code exploitation vulnerability that is potentially exploitable without any authentication. We also want to know if proof of concept code is already available on GitHub or whatever, and that attackers can directly leverage and try to exploit your organization. And that also leads to us to if it's already exploited in the wild. So you have this type of information directly from example from the CISA known exploited vulnerabilities catalog, but you can also get more, other type of information as well from different sources. We also want to take into account if our organization is impacted. So are we running this piece of software, this vulnerable component? Is it directly exposed to the internet? So again, we just weighed our own score. And finally, we also take into account the trendiness of the vulnerability. Is it doing the headlines in the New York Times or whatever? And so, we also take this into account because the management will push hard about working on this type of vulnerability for sure. And in the end, we have our own score, and depending on the threshold, either we are dealing with the emerging vulnerability or we just keep monitoring because we mainly focus on high-end critical CVEs. And I also, not mentioned on the input, but we can also directly input our own CVSS score just by using the calculator available on the website directly up first. So the idea, so initially, this is how it started. So keep it simple, stupid, just using Excel spreadsheets with checkboxes and so on. And in the end, you have the formula doing all of this for you and computing the score and stating, okay, you are dealing with an emerging vulnerability. So it works, and it worked, but that's manual processing, doing most of the time always the same things, the same operational task, looking for Google searches, GitHub searches, etc., etc. So the idea was to automate as much as possible. So at Datadog, we are a company loving automation, API, stuff like that. So the idea, so we created our own workflow where you can just input a CVE ID number, or just, we also have a scheduled workflow gathering all the latest CVE directly from NVIDIA and computing the score for ourselves. And then what's happening is that it will just flag us directly about potential emerging vulnerability, and we have a final decision about, okay, maybe we are really facing an emerging vulnerability, so we would like to work on this. So this is what you get on the latest screenshot, so the Slack message summarizing everything about the vulnerability itself. And in the middle, this is all the computing steps that we implemented in our workflow. So the question is, how can you do that? So API, of course, we are lots of API nowadays, so that's pretty cool. So for example, to compute the score, so to get the information about the score, you can just get the CVE details from the NVIDIA website. So that's one example. You just query the CVE ID, you pipe it to GQ, for example, and extract the CVSS metrics score, so that you have the base score. But you have also the information about is it a network vulnerability, do you need authentication, is it privilege, etc., etc. So that's one example, but there's also some cool project like the Circle CVE search project, which is maybe something to consider because they also take into account other type of sources besides NVIDIA. About the trendiness, so one simple example. Here you can see that, you can just use Google search, just providing the CVE ID in Google. The first screenshot is just, it's a pretty recent critical severity that, for a product I didn't even know, but the score is around 9.1 or something like that. So it's a critical one. But as you can see, you only have 47 results, so it's not attracting lots of people on this type of CVE. The second one, I think everybody already heard about this one, and maybe you spent lots of time on your weekend 2 weeks ago about the XZ library. As you can see, we are facing mostly, 164,000 results, and for the latest one, so it's the Palo Alto Network CVE as well, so with lots of traction for this type of vulnerability. Something else that we can take into account in our workflow, because we have a paid subscription to Feedly, they provide what was before that, so before Elon bought Twitter, we had CVE Trends, so it was a very cool website and initiative where you had all the latest trending CVE. So Feedly is doing mostly the same thing, providing the same type of information, but unfortunately, you have to pay to get access to this, but yeah, we can do it. And something else to take into account is social network mentions. So for example, with Twitter, so again, you need a paid subscription to get access to this type of data nowadays. But yeah, 1 year ago, it was free to just query Twitter and get the different type of information about the trendiness. And you can also use open source instance, let's say, Twitter fork like Mastodon. But again, if you want to get some interesting data, the instance itself must have indexing enabled. One another example is how to get the information about publicly available proof of concept. So for this, we just rely on GitHub API search. So this one, fortunately, is free, so you can abuse it and get lots of cool information about the different repository, how many stars one repo can get, how many forks, and so on and so on. So that's what's the type of information we take into account when we compute our score. But yeah, we also want to just pay attention about that some threat actors also leverage this type of publicly available POC host on GitHub by just publishing malware directly as a POC. So this is one example. There's also some other security researcher just sending fake POC just to lure people and wasting time for them. So why not? But that's not cool. But anyway. And again, we can also use social network mentions on Twitter, Mastodon, and so on, just with the different hashtag. So most of the time, people will include the CVE number in the tweet and hashtag like POC and stuff like that. So again, it's useful to see if it's trendy and if we have a POC, sorry. So in the end, when we gather all this type of information, we just compute our own CV scoring, which is, as I mentioned earlier, keep it simple, stupid, but it works. And yeah, just simple condition and doing some basic addition. So now we are in the example that we are dealing with an emerging vulnerability. So what's happening next? We are creating a case management. So the idea is also to include all the different stakeholders inside the organization, but also to keep track of the different actions taken by the different teams, the remediation, and so on. And also to just keep track of the lessons learned that we had during the incident. We also reproduce the vulnerability itself when it's possible. So for example, when you have an open source project impacted with a critical severity, most of the time you have Docker images available, so you can just pull it and try to reproduce the vulnerability. So this is most of the time what we are trying to do, and we also directly provide some Docker Compose stuff directly on our GitHub repository so that anybody can reproduce the vulnerability themselves. And finally, what we are doing also is monitoring and see what's the activity we can observe in the wild, and Andy will provide you more details about this.
Cool. So yes, our researchers, we kind of sit in the middle between like IR, CERT teams, and CTI teams. So just reports and building this process wasn't enough. So management is like, okay, so we have this structured process on classifying vulnerabilities and how to prioritize them. So let's get some outcomes. So we decided to collect intelligence on when we label emerging vulnerabilities. And then this process started very slow. We are POCers, we are researchers, we're not the best developers ever. So we started with obviously trying to follow best practices. So we started doing with Terraform, so Cloud Provisioner. We chose that just because the support for that it's various in various cloud environments. Ansible to be able to provision boxes and servers. And obviously, this was the POC, so it was currently running out of my laptop. It worked, but it was slow. There was no scalability. If I disappeared, the POC code was gone. If you look at this, this is how it turned out. It was a huge success. We now created a structured process of classifying vulnerabilities. Now we have a process of collecting intelligence. Now, if you see here, this is just the POC code. Like, we have Terraform resources dropping private keys in my laptop. We have Terraform provisioner, local exec, just invoking Ansible. This is just screaming code injection. Like, it just cringes when I see it. So what we did is, Datadog is very sort of DevOps, DevX environment oriented. So we just decided to incorporate that into our process. We stayed with Terraform, which is like obviously the cloud provisioner, and Ansible, and we decided to replace my laptop with CI/CD platform and with runners. Just seemed like a good idea at the time. My laptop was running very slow. So as you can see, we deploy Honeypot to be able to collect intelligence. And one of our colleagues in our sister team of us developed this framework. It's called Hash, HTTP agnostic software honeypot. It's basically, you're able to edit some YAML files and sort of declare an endpoint and return a 200 or return a 400 or return any status code you like. It literally enabled us to just deploy a low interactive honeypot right away as soon as we classify a vulnerability. I highly encourage you to take a look at this project if you want to sort of collect low interaction, initial access intelligence. Here, as you see, it just takes us around 10 minutes to deploy a honeypot once we have declared it that the vulnerability could be emerging. All we do is commit push, and up in the cloud, we have like a region of 4 regions, and we have a honeypot deployed. Here's another example of like the type of data we're getting. So we see a bunch of scanners, a bunch of folks probing, what we call this Confluence, WordPress, Spring Boot. So it all depends on what the latest stack or the latest cool product wants to sort of have a remote code execution. It just varies nowadays. Everybody has one. So now that we collect some intelligence, so we have a process, we collect some intelligence. Well, we have a bunch of customers. So what do? Let's make that intelligence actionable. And then Fred here will sort of explain how we turn that and we hunt telemetry across our opt-in customers.
Yes, thanks. So basically what we are doing, so to hunt directly in our telemetry, we rely a lot on Jupyter notebooks. So this is Python code running in your browser where you can basically do live data analysis, visualization with a very cool visualization library. You can also directly, of course, connect to different data services. So this is how we plug to our data lakes and get the information to hunt at scale. And then something else interesting with Jupyter Notebook is that you can share your notebook and so that your colleague will be able to reuse it and to reproduce what you were working on. And of course, it's also very useful for rapid prototyping when we are working on detection rules, so we can iterate over the different the customer telemetry so that we are able to detect with accuracy the different vulnerabilities. What we are doing as well, so once we hunt into our customer telemetry, we can extract lots of useful information, so IOCs, payloads, etc. So for example, we can get some IP addresses, so either from classical scanners from the internet, but also exploiters, so trying to directly exploit the vulnerability to get a foothold into your organization. So this is, one example you have in the screenshot on the right, so the list of IP addresses that we have, for example, seen trying to exploit a vulnerability in our customer environment. So for these specific IP addresses, we took into account the payload, and also that this IP address is trying to attack at least 5 different customers. We can also grab some specific username in the case of this specific vulnerability, the different credentials used to create an admin account directly in the Confluence server. And we can also gather new exploitation payloads, but also some type of detection evasion with the famous, for example, Log4Shell, GNGI, so they try to obfuscate the different payloads. So this is also what we can gather. So either from our customer telemetry, but also from our honeypots. we can get stagers, and so on. And we can also have a trend about the exploitation itself. So as you can see in the first screenshot, this is what we got, the number of requests we got from the exploitation of our customers. So as you can see, once the vulnerability has been released, lots of IP addresses or attackers or whatever are just trying to see if you are vulnerable. And then as the day goes on, you can see that it's less and less trendy. But we keep monitoring for sure. Okay, that's cool. So once we have all this type of information, we are also storing them in our TIP, Threat Intelligence Platform. So we are using Yeti, which is an open source platform relying on a graph database. You can store the different vulnerability entities, so like in the sticks format. So by default, it comes with the CISA non-exploited vulnerabilities feed, so it will automatically grab the latest KEV vulnerability. You can also, for sure, manually create them. And what's interesting is that, from the vulnerability itself, you can directly link the IP addresses, the different observables you have seen in the wild, to the vulnerability, so that you know that these specific IP addresses or this specific account have been seen when trying to exploit this CV, for example. And you can link the different piece of information like that. What we do also, we do some CVE search, so across all our customer database, just to have a better understanding of the exposure for this specific vulnerability. So we notify our customer directly inside the product, but also our security team. So we have a dedicated dashboard for vulnerabilities, listing all the different vulnerabilities currently inside your organization and the different resources impacted by this vulnerability, so that you can remediate it quite easily, and you have all the different information available. And we can do this at scale by querying all the different customer data, like you can see in the last screenshot, so just gathering all the different information. So now we're going to take some takeaways.
Yeah, cool. So some takeaways from like the process we developed. As researchers, we're able to sort of move faster, have actions and react, so get certain teams integrated into process. So as soon as we declare an emerging vulnerability, threat detection teams get paged, CERT teams get paged. So if they need to look at them, we're also able to publish faster. So let the community know, or let our customers know, hey, we have a detection rule. We analyzed the vulnerability. We created a POC, or we linked the POC, and here it is. Please read about it and have some IOCs and detect in your environment if it's necessary. And for an example, here you have a timeline of XZ, which we incorporated during the emerging vulnerability. So as you can tell, like Andres sort of revealed this here 329, and less than just 4 days later, we had a detection rule, we had a security center that was published for our customers, and we had an advisory published in our website. And then all of this internally, obviously, like SOPs started kicking off, our CERT team started looking internally, see if we were affected. Threat detection team, product detection engineers started their process. So it was just a standard process to sort of react and run faster. And in summary, for our digest is just, we built a process around emerging vulnerabilities. So we prioritize all these vulnerabilities, and we just narrow it down to determine which ones we should look at and which ones we should sort of prioritize. And it doesn't need to be sort of an AI, ML. Like Fred showed, we have a simple conditional statement and just adding tallies. So if it happens to be that the POC, if it's trending, yes, declare emerging vulnerability, and we have our process started. We engage teams, and the structure process starts. And we also developed a way to sort of label our emerging vulnerability and then start collecting intelligence. So we automatically, once that started, we deploy our honeypots out in the wild of that stack. We start collecting intelligence, and we feed that sort of IOCs or TTPs into like our automated process to be able to query telemetry around customers, whether we need to notify them if they're potentially being targeted, if they have been compromised, or if just making intelligence useful, actionable. I mean, if we're just collecting it and we're sitting in our tip and nobody knows about it, then it's not really intel, yeah? And then this wraps up our presentation. If you have any questions or any comments, if we have time, we could take them. If not, we'll be hanging around for the rest of the con.